Architectural is a fun, engaging, inquiry-based learning project that puts students in the role of architects trying to win a contract or tender. Their aim is to design and create a structure that best achieves a client's design requirements, while also striving to make the most stable and energy-efficient structure within the project budget. Working in groups, the students will have to research, plan and execute their design and then present their outcomes to the client, in this case their teacher. The cheapest or tallest structure won't necessarily win the tender. Students will have to sell their idea based on its merits. Students will be required to justify their design and production choices as a part of their project presentation. Students will have to interpret the brief, research what is required in terms of features, stability of the structure, materials used and the overall purpose for the project, and then successfully have their design created using the Lego printer in the Remote Access Laboratory, or the RAL. Students will need to complete this task while working within a budget determined by the client. The Remote Access Laboratory was designed by engineering academics at the University of Southern Queensland. Its purpose was to enable students to use a simple internet connection to access, manipulate and watch the outcomes of experiments using expensive equipment. In order to ensure students fully benefit from this learning exercise, an inquiry-based approach to learning has been adopted. Through incorporating the principle of backward design and employing the GRASPS design framework, this unit of work will integrate the three key learning areas of mathematics, science and technology. The proposed unit of work is outlined as follows using the GRASPS model. Goal. Students will work in groups to design and build a Lego structure using a 3D Lego printer in the RAL. Each initial design will be hand-drawn to scale and then converted into a 3D solid design using CAD technology. This process will be facilitated by a specialist staff member at the RAL. This design will then be created using a Lego printer within the RAL. Lego blocks have a price per block. Different blocks will have different prices attached to them. This is where students need to plan their design to ensure their structure meets the design brief and the budget. The aim is to fulfill the client's brief by creating the most stable structure using an efficient number of blocks, using the least amount of electricity and working within the budget set by the client. Role. The students are the architects working for their client within a limited budget in order to create a structure that meets all of the requirements of the client's brief. The final product must be structurally sound and employ the most cost-effective and efficient design methods. They have to consider structural integrity, stability, criteria of the design, electricity usage and budget. Audience. The groups are working for their client, who in this case is their teacher. The students will also want to demonstrate their design to other groups within the class. Each group will be competing to win the tender. Situation. The students will need to treat this exercise as they would be expected to in a real-life tender situation. Students will need to meet with their client to ensure that they have all the information required for their project. Product. Students will be required to submit their plans, costing per block, number and type of blocks required and the time taken to complete the project. The student submissions may involve a written report, scale drawings of the building, a graph for each measurable component of the design, and the completed Lego structure itself. Students may also be required to deliver this information to their client through a presentation. Standards. The brief supplied by the client will clearly define the criteria the students need to work within in order to successfully complete this task. These criteria will also be used for the assessment rubric for the project. Key learning areas. This inquiry-based learning activity will allow teachers to integrate and assess three key learning areas while stimulating students to draw upon inquiry and problem-solving techniques to accomplish the task. The specific areas covered in this activity include various essential learnings from the key learning areas of mathematics, science, and technology. Additional key learning areas may also be drawn into the project, for example arts and literacy, as the students prepare their design or work on a report to present to their clients. 3. Benefits for the students. As Pritchard stated, we learn best when we actively construct our own understanding. An effective inquiry-based approach to teaching enables students to develop their investigating and thinking skills by emphasizing the process of learning as well as the outcome. As this approach to learning is student-focused, it provides students with the opportunity to regulate their own learning, which aids their development to becoming contributing members of society. By providing students with real-world opportunities and learning tasks, they will have an opportunity to see the direct link between what they have been learning and how this information can be applied practically. Encouraging the students to work within a group also reinforces the knowledge that in the workplace, people are often required to function within a group situation in order to complete a job or project. Some further benefits of this inquiry-based learning activity are: working in groups provides the students with further opportunities to develop their own understanding through discussion and reflection with their peers. Seeing their designs come together in practice, not only theory. Exposure to technologies otherwise not available to them. Practical real-life investigations with learning benefits. Opportunities to demonstrate their skills in areas of learning that may not be readily available in the classroom. Variety of tasks including hands-on approaches to learning that may benefit the different styles of student learning. By employing a collaborative approach, students can work together to build on strengths and/or compensate for one another, demonstrating Gardner's multiple intelligence theory. The inquiry approach caters to the variety of needs of individual students as it develops students' investigative and thinking skills and focuses on the student and their role as a learner, encouraging them to take responsibility for their own learning. The extent to how far a student questions and seeks answers is guided by the teacher, but is very much up to the individual, which is why the approach caters so well to a diverse range of student competencies. 4. Teaching benefits. The use of information and communication technologies, or ICTs, is integral to students' learning today. Students need to become competent, discriminating, creative and productive users of technology. ICTs can be integrated into teaching episodes to enable students to develop skills in communication, research, developing safe technology practices, and evaluating data. Effective integration across the key learning areas of mathematics, science, and technology encourages students to make connections that enable them to benefit equally from the learnings across key learning areas. By posing authentic tasks within real-life contexts for students to complete, they are able to develop the skills necessary to acquire knowledge from that area of learning and use that knowledge to build on their understanding. By taking advantage of the RAL or RAL technology available, schools are offered the opportunity to provide students with an effective resource that enables them to access specialised equipment and technology that is usually too expensive or cumbersome for an individual school to invest in. 5. Resources. In order to develop this inquiry task, we relied upon the GRASPS framework of design. We also accessed and selected from the Queensland Studies Authority the essential learnings for each of the 3 KLAs, which we found to be the most appropriate. The 3D Lego printer YouTube clip was an indispensable resource in being able to comprehend the technique and possibilities our proposed task could offer the students. This resource was known prior to the assignment project and was accessed as a relevant and appropriate example to incorporate into a remote access laboratory proposal. Additional resources utilised included materials from prior study of inquiry-based learning, course readings, course materials, and study books.